Hi everyone, my name is Dr. Ismail Msang, a lecturer in Material Science and Physical Chemistry from United Republic of Tanzania. In front of you once again to proceed with our topic on overview on material science. Last time we discussed the classes of material, including metals and polymers. Today I will concentrate my discussion on ceramics and composites. Starting with ceramics, these are the material which mainly consist of metals and non-metals. And the materials or the components which are metal and non-metals, they typically in a mixture of elements in form of chemical compounds like glasses, which are represented by a chemical compound aluminum oxide, or sand, which is represented by a chemical compound silicon oxide. So typically in ceramic material, we expect a mix of materials in form of compounds. And the nature of bonding in this kind of mixture or combination is ranging from covalent to ionic, that some of material are combined covalently, but some are combined ionically, like silicon oxide, like aluminum oxide, and other kind of ceramic materials. And this material has desired properties, of course, in a very wide range. And some of it include wear resistant, where this material are very resistant to different environments. Resistance to scratches, resistance to wear, resistance to different kind of stresses and disturbances. So generally the materials are very hardy compared to metals and the polymers which we discussed previously. These are the most hard materials compared to them. They are also chemically very stable towards corrosion. That's why even in laboratory, most of laboratory desks are mostly covered by ceramic materials like marble and ceramics, which are very resistant to chemicals. No corrosive chemical which can corrode the ceramic materials like marbles and tiles. And this material has high temperature strength, and this enables the material to be applied in very high temperature applications. Also, the melting point is very high compared to metals and polymers. This is the best performer in terms of melting point. So application which require very high melting point, ceramic could be the best candidate. And they are good insulators also. That conduction of heat, conduction of electricity is minimal in this kind of materials. So they are very good material in application which require prohibition of heat. And on top of that, this material are also adhesive and they have good optical properties. And this makes them to have a wide range of applications, ranging from construction to health and so forth. For example, glasses, which are highly transparent, they are good in in light transmission and so forth. And in addition to that, ceramic material are classified into different groups. And this is one of the class of material which has a wide range of varieties. They include material like glasses, which are mostly used in construction and other appliances, home appliances, and so on. We have clay materials, which ranges mostly used in production of home appliances and constructions, production of white wares and bricks, refractories, which are used in finances. We have abrasive material for polishing, cutting, and so on. We have cements, which are used in construction, and advanced ceramics, which are used in rotors, valves, bearing, and sensors, even in engines. So these are some classes of ceramic materials which are used in a wide range of applications, including window glasses, including application like aerospaces, energy, automotive industry, and so on. So ceramics are used in heat shielding tiles, in airspace crafts, engine components, and that's why ceramic engines are so expensive due to the strength of ceramic materials used. They are used in reactor vessels, finance linings, and so many others. This is in form of energy. And they are also used in production of consumables. Consumables like pottery, dishes, home application, glasswares like cups, mugs, and so forth. You can see from this image here, we have these devices or objects which are made of ceramic material, like glasses for home appliances. We have brakes and tiles for construction, scissors which are used in homes, health facilities, and so many others. So you can see that ceramic is having a wide range of application, even more than metals and polymers. Another class of material is composite, of which this is mostly a mixture of materials. Sometimes, depending on nature of application, engineers need to produce material with combined properties, either combination of polymer and polymer, metal and ceramics, and so forth. But composite mostly composed of more than one component. And nature of the bonding in this composite material will depend on the constituents which are mixed together. But in most cases may range from covalent to ionic to weak tertiary layers. So it depends which kind of material are mixed to produce a composite. And the properties of composite also depends on the mixture, because we mix materials depending on the nature or application where the material is going to be applied. And this may result into different properties. And maybe one of the properties of these composites is high melting point with improved high temperature strength. And this may be achieved when ceramic and ceramic are mixed together. So we may have also high strength and ductility, which may be improved when metals and ceramics are mixed. And sometimes ductility also may be improved when we mix polymers together. So depending on nature of materials which are mixed together, composite may result into different properties for different applications, which includes like woods, which are the naturally occurring composite. One of the best natural occurring composite, the wood, which is having a wide range of application from construction to carpentry to energy, because sometimes wood are used as a source of energy for cooking and other home appliances. Used in carpentry for manufacturing of different furnitures. They also used in construction and so many applications. So you have plywood also, which is a form of wood, but a good example of composites, which is used in laminated in building as laminated wood and so many others. We have also concretes which are used in construction. This is a good example of composite. We have fiberglass, we have carbon fiber resins and other materials which may be produced by combining materials. And nowadays we have different composites which may be used in different applications, ranging from energy to corrosion and so many others, including health facilities, agriculture, security, and so many others. And we have other kinds of material apart from the main four material discussed, including metals, ceramics, polymers, and composites, which are mostly referred as advanced materials. And these are materials which are utilized or used in high technologies like electronics, materials which are used in making CD or DVDs, computers, fiber optics, and so many others which are mostly based on nanotechnology and other high technologies. So this kind of material we call advanced materials are just a result of enhancement of the typical traditional materials. By using high technology, we can manipulate or modulate the available traditional materials to fabricate new material with very high efficiency in applications. And those materials may be referred as advanced materials. Something to note here is that advanced material is not a new category of material, but it may fall under ceramic, under composite, under polymer. But what makes them advanced is due to enhanced properties resulted from different manipulations. So advanced material may include materials like semiconductors and biomaterials, just as an examples. And semiconductor, these are the material which have properties which are in intermediate between conductors and insulators. And in material science, this kind of material is very useful because they can be twisted, modulated easily to produce different desired properties rather than conductors or insulators. And we have biomaterials, which are material which are used to be implanted into human body for replacement or treatment of diseases. So some body parts may be damaged and need to be replaced. So biomaterials are used for that case. Or sometimes biomaterial may be used directly for treatment of diseases. So this kind of material must be compatible with the body tissues and may not produce toxic materials, because by doing that it will harm a living body. And why do we need advanced material? We need advanced material because sometimes we have application which requires high temperatures. So we need material which may withstand very high temperature, more than 2000, more than 300, more than 3000, etc. So we need material with high melting points. We need material with excellent strength. We need material with very high chemical stability to withstand very corrosive chemicals, so as they will be used in high technology. We need material which are light. So this marks the end of today's session, and in next session we will start discussion on alloys. Thank you for listening.